18, we want the whole thing 18?
Yeah.
Yeah. Okay. So for number 18, let me start there. So they give us a graph and they want, this would be worth like throwing a picture up of this. Okay, so I'll try to just sketch this just to save time a little bit here. So it's not, it might not be perfect. Let me see if I can get a couple points here to make it help. So it looks something like that. All right, so this is essentially what's going on here. So they wanted us to find out what happens at f of -1. So that means we go to the graph and we identify what's happening at -1. So -1 is here. So f of -1 is this point here. So where does the graph intersect at -1? So that's about, I think we said about like 1.6, 1.5, 1 point, whatever you thought was something in between 1 and 2. It definitely wasn't 1 and it definitely wasn't 2, so somewhere in there. So something close to that is fine. So for what values does the function f of x, so like this is about, I guess I'll say 125. What values does the function equal 0? So this is asking, where does the graph equal 0? And where 0 is this horizontal line. So this is where f of x equals 0. And if this stuff isn't clear, that's why we practice homework. That's why we have to make sure we're, figuring things out and learning things. So learn from mistakes if we're making them. And the way I know they're looking for x values is because the x is unknown. So when they don't have an x in there, I know they're asking for x values. When they put a value in, that means that is the x. So I don't know if that helps a little bit. So the values where it hits 0 are these three values. So it's x is -2, x is 1, and x is 4, I think. So that's this. That's where it equals 0. Then they're asking above and below 0. Now, if you got that one wrong, you probably got these next two wrong as well, or maybe just because of the fact that above and below 0 is basically, are you understanding when we're above the line and when we're below it? So, in this case, above 0 is this part of the graph. So the green is above 0. So I'm basically writing an inequality to say when that happens. So it's in between -2 and 1. Now if you use the equal to or not equal to, it's fine. It's kind of a debate between math people, whether or not it should be equal to or not. And then over here as well, so anytime it's greater than 4, it's also going to be above 0. I guess it should just be greater than. I guess the equal to is 0, but. Then below is the other half of this. So that's down here. So that's to the right here, so less than -2. And then in between 1 and 4. And then it asks, when does the function equal -2? And that is they're asking what the x is again, so that's kind of a clue to me. I'm looking for x because x is unknown there. So in that case, -2 is here. So I'm thinking we're looking for this point and this point. So what values does it equal -2? So it looks like about -2, -3, I guess. And then also, what is that, like 2.5? Or no, it actually is a point, it's 2. So those values is when it equals -2. All right, so then moving on to number 4, we're looking at A and B. Oh, so these two, I should have been clear on this. Number 4, I think, is one that I actually went in and even asked Mr. Hatfield, like, if you would have been able to do that. You should have been able to do that by hand, and we didn't, so I apologize. It says to estimate the range, or calculate the exact range, and then estimate using a grapher. So I should have just said, just do it by graphing. So the equation in this case, I might actually pull up my Desmos for you guys. Let me do that. And again, if you haven't got your hands on a graphing calculator, please look into it, ask around. There's going to be people that have them. Oh, there's Desmos. Again, if you're like underclassmen and you're taking math next year, you're going to need it anyway. Like Mr. Hatfield said, everyone walks in with a graphing calculator for AP classes, you know, so like thinking of that if you're considering, if you're taking any math in college, it'd probably just be a good thing to have. My calculator finally like died after like 25 years of having it, so I'm actually considering purchasing one myself because I want one for in here. Mr. Itzon's going to come down later though, and he's going to put a graphing calculator on my board that we can use and see. So, all right. So my graph is way up here. So if you ever struggle to find your graph, it might mean you have to change your windows. You can either zoom out or change your window, kind of you have to look for it. So if you weren't able to find it, maybe that was part of the issue. Or you probably saw like the very bottom of it, maybe, I guess, because it's down here somewhere. So when we graph this, I believe this is correct. This is what our graph should look like. So our range then is basically, the range is the y values they wanted. So the y value is 8.667, and it's 8.667 and above. So y is greater than or equal to 8.667. It's never to come back down again. So just knowing that shape of a parabola, it's going to go straight up. So it's y is greater than or equal to that value. You didn't have to find that exact value. Yeah, I was trying to think about how you would be able to, so yeah, don't worry about that. Number 13, E and D. So in 13, again, they're going to give us a graph here. Let me sketch what our graph looks like. So our graph in this case for E and D, so kind of, I'm just going to sketch it quick just to save on time a little bit here. So that's what our graph looked like, sort of. And it said, find all x that at h of x is -2. So that now this is really similar to what we just talked about. So you go down to your graph and you look where it crosses -2. And this graph actually crosses -2 like 3 times. And mine's not gonna be great to show that because of the fact that I didn't sketch it very well. So all the places it crosses -2. And then when is it less than 0? So again, they're asking for these intervals. So these are really similar to questions of what we went through in 18. So it's less than 0 from here to here, and then from that little section as well. All right, questions there? So let me get you guys our notes for today. Yeah. Weakling. Move along. And she's probably so sweet she doesn't say anything. She sits back there.
There it does, though.
Oh yeah, I suppose.
Very sweet.
All right. The warm-up question is asking you guys to review some Algebra 2. So if you guys remember how to factor that completely, so factoring, if it helps when we had 4 terms on how to factor that. So I'm going to take a minute to try. Some of you haven't had math for a while, so the factoring might be a little bit rustier than other things. Reminds me of here and not being here, so I can turn this quick. Well, not just because of that, but they're reminding me that people aren't here. I'll put like some little marks up here that maybe might help jog your memory if you forgot. So like you break them into 2 parts, then you group each of those separately. If not, we'll talk about it. That's why we review. Right, Cash. Does this jog your memory? Does anyone remember this?
I do.
You do?
Yeah. I just don't know if it's
Okay. Yeah, the kind of the last steps are probably like get a little wonky. So if you guys recall, this is we factored by grouping, and you did learn this in algebra as well. So I mean, you've seen this a few times. So put your phone away, please. So we have these 2 terms. We look for the common factor there. So between those 2 terms, what can I take out? Just an x squared. So out of those first 2 terms, I'm just going to take out x squared. So I'm factoring it separately. So taking an x squared out of this, I'm left with an x. Out of this, I'm left with a -2. Oh, shoot. I think the signs are bad. I think I want to change that to a plus 18. Otherwise it won't work. That's probably why you can't finish it.
Or I just took out.
So change that to a plus 18, sorry, my error. If it's plus 18, I think it'll work now. Now between the negative 9 and 18, what can be pulled out? A negative 9? The reason why this I had to change that sign is then they wouldn't match, and we need them to match. It's part of the trick with this. So the negative 9 pulls out, this is left as an x, that would then be a negative 2. And had that not been a positive 18, this wouldn't have worked. So the reason why factoring by grouping is special is that the same thing should always come up twice. So the x minus 2 happens twice, so we're going to pull that out now as our common factor. So that's our common factor, and then I write the leftovers. What's left over? The x squared minus 9. Do you guys kind of remember that? Sorry, I should have had the column written. Yes. Oh, that's where you got to. Good. So so if you get there, do you know if you're done or not?
No.
You're not quite done. There is something else you can do. You could have stopped. This is factor. It's just not factored completely. Does anyone remember what else we can factor here? It's another review here.
X squared minus 9.
Yeah. Do you remember how to factor that, Kat? It ends up being 2 sets of parentheses.
Oh, x plus 3 times
There.
x.
There you go. So it's x and x, because that's where the x squared comes from. And in order to get 9, but then get that middle term to cancel out, we do plus 3 and minus 3. And if you forgot that, that's totally okay. That's why we review, and that's why it's not, we're probably not going to use this today. We're going to use it later in the year. All right, so this is now considered factored completely. All right. Do you guys have your, so I'd like you guys to grab your graphing calculators if you have them, or get decimals out, whatever you guys are using. Again, keep on practicing this. The more we can practice it, the better. I want you to graph this, but graph it with the plus 18 in it. So graph this in your graphing calculator with the plus 18, so like my typo should be fixed. So again, if you have decimals, and everyone should be doing this. Everyone should at least have decimals. So that means get your computer out, type in decimals. If you don't have a graphing calculator, these should not be that you guys are just observing. Guys, let's put this in, please. And that way we can figure out that we're doing okay with this. So it should be x to the third minus 2x squared minus 9x or plus 18, sorry. So fix that piece of it. Remember to fix that in my notes. So this is what we're graphing, the plus 18. So you're going to hit the y equals button. You'll type it in there, so type in the equation. And you want to use the x that they have here. So like x, and then raise the power, and use a little caret button. And then type that whole thing, the third power, I think. What?
I did switch that.
Oh, I guess 11. It likes doubling up on whatever I had. Thank you for catching me. The grand scheme of things is probably not too big of a deal, but that's what they told me. Okay. Going on. So if you can't see the whole thing, I want you guys to get, you know, better about playing around with the window, like zooming in and out. There's a zoom button on your screen, and you can zoom in or out. You can use that as an option. And like those of you guys who are using Desmos, sometimes the finger drag gets kind of annoying. Yeah.
Oh, you can squeeze the axis.
Oh, you can actually squeeze the axis. So what Cash pointed out is on Desmos, I don't know if I can do it up here. Yeah, I don't know. He said you can squeeze the axis, so like you can kind of make it, it's probably easier to do on your phone than my screen, that you can see the whole thing at once. And if you want to play a little bit around with the trace function, like playing with trace and kind of going through the graph and kind of seeing how that moves and stays on your graph. What I wanted to point out, guys, is something about this graph and kind of trying to make that connection back to when we did factoring and why we ever even needed to be able to factor a problem like we did in the warm-up. What I'm going to do is I'm going to make little dots at our zeros. So where the graph hits the x-axis are what we call our zeros of our function. So this would be -3, 2, and 3. I want to point out why those points are so important to us for our graph, but then also for like the equation we did. And this is kind of trying to make that connection between graphing and just being a little factor. Did you get it to work? Oh, so then, yeah, you got it. And again, it's just a matter of playing and getting used to it. So looking at so I have, I'm going to write them over here. So I have x is -3, x is 2, and x is 3. So if I wanted to know when does f of x equal 0, I would say -3, 2, and 3. So if they were asking me when does the function equal 0, that's what I would tell them. So going back to our original problem, do you guys remember or see how we would get those numbers from this? Do you see that? Where would those come from? They're -3, 2, and 3. Yeah, what's that?
You plug in the x to 0.
Yeah, so you're trying to make 0. So 2 minus 2 is 0. -3 and 3 is 0. 3 minus 3 is 0. These are the values that make this function equal 0. So like the fact that the graph showed us that and the factors show us that, like this all connects. This isn't just like she made us factor to be miserable. Like, I mean, it's supposed to show you that this does actually work. And you could have actually factored the equation, or you could actually graph the equation in this form, and it would actually graph the exact same line. It's just another version of it. So it's just like the fancier version to write it, okay? So I'm trying to make some of those connections to help you guys to see this isn't that far off from stuff we talked about before. It's kind of out of context. It's a new way to look at it, and it's been a while, so it's understandable if we're a little bit rusty. All right, so the next 4 vocab words we're not going to use a whole lot right now, but I just want to list them so we have them in case I mention it or that it comes up. And this kind of goes back to when we graphed, like, or we talk about, like domain being like from this value to this value. An open interval is like when we have an and inequality, but the zeros are the lines aren't included. So like if I have, it goes from -2 to 3, is considered an open interval. It's from -2 to 3, but those aren't included. So we don't include the endpoints. A closed interval, what do you think that means then? It's exactly the same thing. The endpoints are included. So basically it's the same problem. It's just now we include those as part of the solution. And this shows up a lot with domains, talking about, you know, is 2 a valid answer? Like, is that part of the domain or is it not? Like, is that kind of one of the cutoffs? Half is just 1 open, 1 closed, kind of like what you maybe would expect. So, based off of the other 2. It doesn't matter which one. Any idea what infinite intervals would be then? There are no, well, there technically are endpoints, but what's the other way the graph could look? Rather than going in, it could go out. So this is like when we say like so like there's an excluded part, but then like it goes on forever in either direction. So this obviously comes up like when we go either direction here. Now this one, it doesn't matter if the circles are open or closed. The infinite idea is that it goes on forever. So it doesn't have the endpoint on the one side. So they can be open and closed, but they do go on forever. Like we couldn't list all the answers for these. We have like a limit to what we can mention. All right, good news is today's gonna be a lot of the same stuff we were talking about yesterday. And maybe with us not being super comfortable with the homework, like maybe this will hopefully help you guys feel a little bit better about it. Did I lose some of my, did we do, I don't think I missed some vocab. Do you have space still underneath those?
Yeah.
Yeah, can you, so I'm gonna ask that you add a couple, I don't think I put it anywhere. I don't know how I missed that. So I didn't define relative maximum or minimum yet. We did maximum or minimum, right? But not relative. So I'm gonna write those out here. Sorry. Oops. So relative max or minimum. What that means is when we're looking just at a certain section of the graph, because the problem we did with our decimals, so talking about this problem is technically this problem has no max or min. Let me, oops, other way. Go. It's going to be difficult for me, of course. This problem technically has no maximum or minimum point because it really goes on forever. So if I was looking for a minimum point or a maximum point, it would be like negative infinity. But what I could ask for is a relative maximum, because that sometimes that's going to be more helpful. So that's what those points are. Technically, they're called relative maximum and minimum points. So like in this problem, I would say like in between, you know, like 2 values, what is my maximum and minimum? So when we're looking for a graph that is this big graph that keeps changing direction or it goes on forever, we can locate that between 2 values. So it's where we find the max or min between 2 values. And I'll show you guys what we mean in an example. So we're going to use a specific, what we call window. So we're going to kind of like close our view down a little bit more specifically. Okay, so let's look back at, so once you have that down, it asks on our graph here, this graph, so example 1 is for the little graph at the right there. On what intervals is the graph increasing, which ones is decreasing, where is it constant, and then any relative maximum or minimum values, and again, that's just talking about specifically, can we look in our window that we have here. So we're going to use this as our kind of our window. Notice the arrows on the end, just kind of being aware of that. Okay. So in what intervals is the graph increasing? When they're talking about intervals, they just want you to write that with like an inequality. So increasing. So from where to where is the graph increasing? 0 to 3. So from 0 to 3. Now, this is like, so you can talk about our cool lunch conversations. It doesn't happen as much here, but when I was at Cedarburg, we had like 10 math teachers, and we would all eat lunch together. I know, you're really jealous. But we actually, one day, a few of the teachers felt very strongly, and they had like an argument or debate or whatever about whether or not we should use the equal to line here. And I was kind of like, I don't really care, just tell me what you want me to do. Like, so, like, just so you know, there's going to be people that want you to use the equal line, and other people who won't. I don't know where Mr. Hatfield stands on things. We have not brought that up at lunch yet. But from 0 to 3, the graph is increasing. If you do the equal line or you don't, it's really up to you. The book, I don't remember if it does or not. I was kind of trying to, I think they use the equal to line. If you want to stick with like the book, that's fine. So take a minute. What intervals or interval is the graph decreasing? Or is it decreasing? So there's no like end of where it starts, so it's decreasing all the way coming in here until it hits 0. So everything smaller than 0, it's actually decreasing across that whole thing. So we'd say x is less than or equal to 0. So anytime x is on that side of 0, we're assuming it's going downhill. Now you don't have to like say, well, what if the graph isn't doing that? Like maybe it did something else. Like you don't have to try and guess what else the graph could be doing. Just assume that that's the way it's pointing, that's what's happening. Are you okay with that? On what intervals is the graph constant? Remember constant, that constant in your life, the person that just never changes, their even keel, 3 and above, right? So x is greater than 3. And really, if I ask these 3 questions, basically the whole graph should be covered. There's not a lot of other options there for it's either increasing, decreasing, or constant. All right, so relative max or mins. Now, typically they would set a window for us. Let's say this is our window. What's our relative max or min? Because technically, there should be no relative maximum. This should really go on forever. But let's use this as our window. So like pretend that that's all we know about it. This is the relative view that we're looking at. So it stops right here. So max, what do you got? 3. So the highest it looks like it goes is 3. Now that's a little bit, that's fake in terms of if it like a absolute maximum, it does go on forever. We're gonna say it's 3. And it's the graph is 3, so I don't think they gave us a name of this function. So you could either say y equals 3 or the function equals 3. And what's the minimum? 0. And now that's an absolute minimum. Oops, not x, y, or the function. That's the lowest it'll ever go, as far as we can tell from this graph. All right, so this next problem, I want you guys to graph this, and we're going to use this interval, like this window. You don't have to change your window, but you're basically, you don't care about anything smaller than -1, but greater than 4. So if you guys want to try this one in terms of finding increasing, decreasing, and max and min. -1 to 4. They want us to -1 to 4. So essentially what I have like highlighted there in the yellow is what they want us to look at. I probably should have shrunk it in a little bit more in order to get a real true maximum and minimum, or like relative. I probably should have shrunk it in almost like a little bit further, but oops. Okay, so when is it increasing and decreasing? It's increasing twice, right? What did you guys say? So it starts off by increasing, right? So it increases till when? Can you guys tell when it switches? What was that, 1.3-ish? Are you guys able to find that? So like if you're getting used to this, are you finding that by either tracing? Actually, did I type it in wrong?
No.
So is that, oh, 0.3-ish. Is that what you said? I just said 1.3-ish. I don't know. right? Is it increased to 0.3 about? Okay. 0.2, if you want to go I don't know how exact yours gets. So increases when x is less than 0.3 or 0.29 or 0.28, something like that. I don't know, like I said, I don't know how accurate. And if it helps, then then it decreases, if that's useful for you guys to like switch right over to that. It decreases from that spot to the next one, right? Which is like 2.4-ish. And we're looking at the x when we talk about increasing and decreasing. So this is, I'm going to take this point, so there's kind of no gap there. And what did I say, 2.4? What's that?
Yes.
Yeah, 2.4. So increasing, decreasing, and then it increases again from 2.4 on, right? So you don't have to, when they set our window, we don't have to like stop our increasing and decreasing. So you don't have to say it stops at -1, like you don't have to worry about that. I mean, I guess you could say that if you don't want to be particular. Now max and min is a little bit rough because I checked my window very closely when I did this. Max and min technically should be tucked in a little bit more, but the max and min points, relative max and min, you kind of get the idea, now these are our y values, the highest point and the lowest point. If I could just shrink in and look at the part of the graph that kind of seems most useful, if I could kind of cut off those extra like parts that are going all over the place. So I would use those two values, so like the 3.3 and the -1.4 would be relative max and mins. I just didn't shrink the liquid small enough. So 3.3 and -1.4. Oh, not x, sorry, y, the function. And it takes some getting used to, I mean, obviously, because I keep messing it up too. I think -1.4. So when we're checking the intervals where they're increasing, decreasing, they're talking about x. When we're talking about max and min values, that's how high the graph is going. So that's the y or the function value. All right. I'm probably just going to take a quick break here because we still have another